So I was watching this video on YouTube recently about the primitive obsession smell, code smell, right? Where basically you're using strings and ints where you should be using a custom type. The author was showing an application that was doing that in its core, right? So in your domain entities or domain services, that application had a lot of what he called trivial guard clauses, right? Null checks, checks for empty strings, checks for, zero ints, things like that. And the author was advocating for moving that to that kind of precondition logic to value objects that would then be instantiated at the edge of the program, right? So maybe in your controllers in the web project. And then those instances of those custom types can be passed into your domain. And the idea is that the domain at that point doesn't have to worry about whether or not, that string that they're getting is properly formed, if it's null or if it's empty or whatever, because they can feel confident that the type they're getting takes care of all that precondition stuff. It enforces that contract. And that's a great idea in practice, as well as in principle, I guess. The problem is that in that particular video, the author was implementing that value object using a struct. And there is an important gotcha with structs, especially when you're used to classes when it comes to their constructor. So let's dive into the code and we'll see that together. See if I can bring that up. Okay. All right, so here's almost a copy-paste example from that video I watched where we're using a read-only record struct of username, right? So it's meant to wrap a username string, basically. Very simple. We've got our username constructor passing the string. Here's your guard clause that we're encapsulating. We're checking for null or empty. If we get a null or empty string, we throw. Otherwise, everything's good. We're saving the value, and we can access that value using an override of the toString method. Great. Nothing too complicated. Let's use it. So we're going to create an instance of our username. I was going to say class, but struct in this case. And we're going to pass in a string of name. Now, what do you expect to happen when I hit run, right? You expect it to say the value is name. Yes, and it does. It should anyways. Well, it would if I would pass in name to our console write line. There we go. So the value is name, and that's great. That's the happy path. That's what we expect it to do. Now, does it enforce our contract that it should never be null or empty? So let's try an empty string. Great. We're getting our argument null exception here. That's what we expect it to do. What if we pass in null? We should expect it to throw as well. Perfect. Great. So at that point, you think maybe, okay, this is doing exactly what we expect it to do. What's the problem here? I don't see a problem. And you might be thinking that because you're not used to structs as much as classes. But structs, when it comes to constructors, work a little differently. And in this particular case, that can be a problem for us. Take a look at this. I'll just remove null from here. What would you expect to happen here normally, right? If we were using a class, you would think that the ID would be complaining, hey, I don't have an empty constructor, right? But the ID is not complaining here. That's weird, right? We didn't define an empty constructor. We defined a constructor that takes in a string. Can we even run this? It looks like it's compiling, right? That there's no error. Let's run it. Oh, what is going on? The value is blank. Well, it turns out that we were able to instantiate, and we were able to instantiate with passing in a string, and there's no error. The program continues, which means that, if we were using this as that special value object that enforces our contract that the wrapping value should never be null or empty, well, then we're failing. That's not true, right? We can't be confident that if we're getting an instance of username, that contract will always have been enforced. And that's a problem because that's the whole point of doing this here, right? So for that reason, if we're thinking of using a value object to enforce through the constructor some sort of logic, probably better off using a class. And if we switch to a class, immediately the compiler is complaining, right? Because we don't have a definition of an empty constructor. Now we're safe, right? Now we can feel confident that if I get an instance of username, it will always have a value of string, and that string is not going to be null or empty. But the question remains, why do struct behave that way? What's going on there? Let's come back to our struct. It turns out that, well, actually, you know what? Let's keep going with the class here for a second. So if we construct or define oh yeah, I can't use my shortcuts here. This online ID. I'm just going to comment that out. Right, great. So we don't have a definition for any constructors here, empty or otherwise. And because of that, and you're probably familiar with this, right? Because classes, we're used to classes in C#. The ID is not complaining. It's allowing us to instantiate username using an empty constructor. The reason for that is that by default, classes have a default constructor that is empty. So if we're not defining a constructor, there is one for us. There's an empty constructor. But the minute that we define a constructor in a class, C# will basically make that our new default constructor and get rid, essentially, of the empty constructor in practice, right? This is why it's saying now, hey, you can't, there's no empty constructor here. You can't do that. If I was to pass in a string, though, then it'd be happy because we have that, right? Run it, value is name, great, everything's fine. All these preconditions would be checked, everything's good. But what if we wanted an empty constructor? You can, right? We're probably used to this as well. So we could define our own empty constructor. And the compiler will be happy, right? There we go. Well, it doesn't make sense to do that here. We don't want to do that. But the point I was just making is that classes work that way, right? You have to be explicit about having an empty constructor the minute that you have another kind of constructor because you've overridden the default empty constructor. Structs don't work that way. Let's go back to our struct. Okay. Structs by default, maybe I shouldn't use the term default, but anyway, struct, you could think of it this way. Struct always have an empty constructor. Even if you define your own constructor that takes in parameters, that empty constructor will always be there. So here's a workaround. If you're dead set on using a struct for implementing something like this, where there's some contract or preconditions or some logic that has to be checked in the constructor, where you don't want it to be possible to instantiate that struct without these checks, that logic being made, right? You can, just like as in classes, define your own empty constructor, and that will override, the default empty constructor, if you will. But the thing is, what are we trying to do here? We're trying to exercise that check here. So what you can do is delegate to that other constructor, passing in a null, and that, like this, that should go away. Yep, and we should be able to run it, and we should get our exception. Yes, because essentially we're instantiating using the null, the empty constructor. Empty constructor delegates to our other constructor, which then throws an error because we're passing in null. So at least this way, with this little hack, if you will, at runtime, you can feel confident that your username instances will always enforce your contract. Problem is, at compile time, it doesn't, right? We're able to instantiate username without passing in a string, which is kind of like the opposite of what we're trying to do here. So for that reason, it would probably be preferable, as I've said, to use a class for this kind of behavior. So I hope this was helpful. If you do know of a way to instantiate a struct and enforce this kind of behavior in the constructor, and basically at compile time prevent the use of an empty constructor, I would love to know about it. Please tell us how you do that in the comments. Otherwise, if you like this video, please press the like button. And if you like this kind of content and would like to see more, feel free to subscribe to the channel. See you next time.